So here we are again. Let's continue from the part we leave yesterday. Here, hash map. Music is already playing. Let's bring this to here. Here. And start the clock. List hash map. Hash map is implemented as an array in which every element includes a list. The list contains key value pairs. The user can search from the hash map based on the key. They can also add new key value pairs into it. Each key can appear at most once in the hash map. The functioning of the hash map is based on the hash value of the key. When a new key value pair is stored in a hash map, we calculate a hash value based on the key to be stored. The hash value decides the index of the internal array. Will be used for storing the key value pair is stored in the list that can be found at that index. Let's sketch out how a hash map functions. Key value pair. Let's start by creating the class pair that represents a key value pair. We want to make the hash map as general as possible. So the type of the key and the value are determined at runtime. The pair class contains a key and a value, as well as the related get methods. The generic type key and v are named after the words key and value. Creating key value pairs is straightforward. Creating a hash map. A hash map contains an array of lists. Each value of the list pair described in the previous section and contains a key and a value. The hash map also knows the number of the values. Here we have at our disposal the previously created class list. Retrieving a value. Let's implement a method called public_v get. In the user to search for a value based on a key. The method begins by calculating a hash value for the key and using it to figure out which is the relevant index of the internal array of the hash map. The hash value is calculated with the hash code method that each object has. The modulo remainder of division operation is used for ensuring that the index stays within the defined boundary of the internal array. There is no list in the calculated index, so key value pairs have been added to that index. This means that there are no key value pairs with the key that have been stored. In this case, we will return the null reference. Otherwise, the program goes through the list at the index. We compare the parameter key to the key of every key value pair on that list. If some of the keys matches the parameter key, the method returns the value of that key value pair. Otherwise, we cannot find a suitable key related value, so the method returns the value null. Why not implement hash map as a list? The main principle of the hash map is that the key value pairs are divided into smaller sets with the help of hash values. In this case, a search based on key demands only going through a very small number of key value pairs, assuming that the hash value calculated in a sensible manner. If the hash value is always the same, example 1, internal implementation of a hash may be similar to the list. All the values are on the same list. The hash values are sufficiently random, the different values are as evenly distributed to the different lists as possible. Hash maps also grow the size of internal array. If the number of values become larger enough, typically 25% of the size of the array. Typically, a hash map that contains millions of key values pairs only contains a few key value pairs in each index. Practical consequence is that discovering if a key value pair exists, you only need to calculate the hash value and examine a few objects. This is very significantly faster than going through a single list that contains the entirety of values. Adding to hash map, let's implement the first version of the method public void add, which is used to add values to the hash map. For this version, we are not going to increase the size of the internal array when few values are added to the hash map. The method first calculates the hash for the key and uses it to determine the suitable index in the internal array. If there is no value in that index, it relates to that index. After this, the method goes through the list at the index and looks for a key value pair whose matches the key of the key value pair to be added. If the matching key is found, the value related to it is updated to match the new value. Otherwise, the method adds a new key value pair in the list, in which case the number of stored values is also incremented by 1. Incremented by 1. The method is quite complex, so let's divide it into smaller parts. The first part is responsible for finding the list related to the key. The second part is responsible for finding the key on that list. Now we can write a somewhat clearer implementation. Oh, 2 in a row. Now we can write a somewhat clearer implementation of the method. We look for that. Adding to hash table part 2. The way of adding to a hash table that was described above works partially. The greatest fault of the functionality is that the size of the internal array is not increasing when the number goes too large. Let's add a growing functionality to the program that doubles the size of the internal array of the hash map. The growing operation should also place each value in the hash map into the newly created array. Let's catch it at the beginning of the growing functionality. The responsibility map should create a new array whose size is double that of the old array. For this, it goes through the old array index by index. Counter key value pairs are copied into the new array. Finally, the old array is replaced with a new one. Below there is a first version of how the method should work. We haven't implemented the copy yet. And let's begin to create a method that copies the list of the value at one index of the old array into the new one. When copying a location, each key value pair is recalculated over the new array. This is done because the size of the internal array grows, and we want to distribute all the key value pairs in that array as evenly as possible. Below is in the algorithm that copies the value of a hash map to the algorithm in this private copy. In the functionality of this method line by line. For each row we describe why it exists. Example. That is what is its concrete rule and what happens in the row. It's a list with objects from pair with the array list with generic with the generic parameters from there. The other is an integer. starting point. Then for loop, then so iterate over the values then next here object call then where we receive the value receive the value. After this, we create a new int hash that it'll receive the press division between the get e hash code and in the client the given list the start of the method then an if statement to check if the previously is on the list. If it doesn't exist, then a new will be created. The end. The pair object will be to the at the end new one to the we added it to the value calculated earlier. Calculated earlier. At the end, the pair object will be added to the hash value of calculated earlier. To the
Non più tra i farfalloni amoroso, notte giorno di torno girando.
I don't know, probably there's a lot of mistakes here, but who cares, huh? Who cares, man? Now you can call the copy method from the grow method. Finally, let's add the growing functionality to be part of the add method. We want to grow the size of the hash map with the number of key value pairs, and it is greater than 75% of the size of the return array.
Non chiudrai farfalloni amoroso, notte giorno di torno girando, delle belle turbando a riposo, Narcisetto a Tocino d'amor, delle belle turbando a riposo.
Move, let's give the hash map the functionality to remove a key value pair based on key. The removal functionality returns no if the value cannot be found. And otherwise, it will remove the value that is paired with the key to be removed. You can take advantage of this method you've already implemented in the removing method. Explain to yourself out loud how the method described above below concretely works.
Per montagne, per valloni, con le nevi e salioni, al concerto di tromboni, di bombardie.
Implement the class hashmap in the exercise base, only along the lines of the previous example. Unlike the example, implement the class so that it uses the ready-made Java class ArrayList in its internal implementation. There are no tests in the exercise base. Test its functionality with the examples, the material, and with your own experimentation. This exercise is worth 3 points. Right, it's just a couple paste. So another one done. I was forgetting that we need the list to do hash map, to create a hash map. But here, as we can see, everything just working. Search performance. Let's compare the performance of searching from a list or a hash map. To evaluate performance, we can use the system nanotime method and the value it returns, which represents the time as nanoseconds. The program first creates a hash map and a list, which contain 1,000,000 elements, to which 1,000 randomly chosen values are chosen from both. Choosing values are from both. Roughly 50% of the values are found with both structure. The list and hash map that are described in this chapter do have some difference from the ready-made tools we use elsewhere in the course. The data structure offered by the program language have more different kinds of optimizations. Other courses go more in detail with this specific. The sole purpose of this course is enough to know how to use the data structure and to have some idea of the performance difference and when they are suitable to use. Randomness. Learn objectives. Know how to generate random numbers and for some situation where random numbers are needed. You can use Java random class to generate random numbers. Encryption algorithms, machine learning, making computer games less predictable all require randomness. We can model randomness using random numbers. Java offers ready-made random class for creating random numbers. An instance of the random class can be used as follows. We create an instance of the random class. It has nextInt method, which gets an integer as a parameter. The method returns a random number between 0 integer or 0 integer or 0 minus 1. The program output is not always the same. The possible output is the following. Write a program that prompts the user for how many numbers should be generated and then print the numbers. The printed number should be within the range 0 to 10 below or some examples.
Should old acquaintance be forgot and never brought to mind? Should old acquaintance be forgot and all lang syne? For all lang syne, my dear, for all lang syne, we'll take a cup of kindness yet for all lang syne. For all lang syne, my dear, for all lang syne, we'll take a cup of kindness yet for all lang syne. For all lang syne, my dear, for all lang syne, we'll take a cup of kindness yet for all lang syne.
We can use the next int method to create reverse randomness. For example, we might need a program to give us a temperature between -3 to 50. We can do this by first create run a number between 0 and 80 and then subtracting 30 from it. Die. The exercise template contains a class die, which has the following body. Modify the class such that the constructor die creates a new die object with a given number of bases, that is the number of sides. with the number, also modify the method throwDie, which returns the result of a random throw of the die, which should be available within the range 1 number of faces. The following is the main program for testing the die. A random object can also be used to create random doubles. This can, for example, use for calculating probabilities. Computers often simulate probabilities using doubles between 0 and 1. The next double method of the random class creates random doubles. It is similar to the weather. All of these probabilities. There is a 0.1 probability it rains 10% versus the 0.3 probability it snows 30% versus the 0.6 probability that the sun shines 60%. Let's create a weather forecast using these probabilities. To make it a forecast method is interesting in many ways. This randomness Gaussian is a regular method. However, what it is interesting is that this method of the random class returns a normally distributed number. Normally distributed number can be used to, for example, model the height and weight of people. If you are not interested in different kinds of randomness, that is okay. In the previous example, we use explicit typecast to convert doubles to integers. We can equally convert integers to doubles with double integer. Let's now add a main, which uses the weatherman class. The sun shines -2 degrees. Lottery. Your assignment is to complete the class lottery roll, which is used to draw the week's winning numbers. The numbers are in range 1, 40, and 7 numbers will be drawn in total. In other words, a lottery roll consists of 7 different numbers that are all in range 140. We wish to implement the following functions in the class. The constructor lottery roll creates a new lottery roll object that contains new randomized numbers. The method numbers return the drawn lottery numbers of this lottery roll. The method contains numbers tell whether the given number is included in the drawn numbers. The method randomized new numbers for the lottery roll. The following main program is supplying the exercise base. The same number can only appear once in a lottery roll. The numbers don't need to be ordered. So let's go to the next. In fact, there is no next. Not on the subchapter 4. In fact, 3. Subchapter 3, randomness. Randomness of numbers. Randomness of numbers. You can predict how computers work because they is lavishly execute any command we given them. The random numbers generated by a computer are really random. Random numbers used by computers and programs are typically pseudo-random. They seem random numbers, but in reality they follow some algorithmically created series of numbers. Most of the time, pseudo-random is good enough. For example, the user will not notice any difference when YouTube random play is pseudo-random. On the other hand, if random numbers are used for scientific calculation, the weak pseudo-random numbers generated can lead to questionable results. One example is IBM Randu, which was used for a short while in the 60s. Our randomness in computer programs is not pseudo-random. Programs aiming for stronger randomness use, among other things, real-life random phenomena to generate random numbers. For example, space radiation or lava lamps are thought to be random phenomena. You can read more about randomness from Randomness. You have reached the end of this section. Continue to the next section. Multidimensional data. Objectives. No ways to represent multidimensional data. You can create and use multidimensional data. Multidimensional array, in fact, data is in up, arrays and down. Previously, we have used a one-dimensional array, where the index tells us the location of a value in the only dimension. You can also create multidimensional array, and we need the indexes of a value in each dimensional to access the value. This comes handy when our data is multidimensional. For example, when dealing with coordinates, a two-dimensional array with 2 rows and 3 columns can be created like so. In the array we created above, each row refers to an array with a certain number of columns. We can iterate a two-dimensional array using 2 needs for loops. So. program output is as follows. You can see that the default value of variables type int is 0. You can change the value in the array just like before. Below we set new values to 3 elements of the array. Array as a string. Create in the exercise base a method called public static string array as a string. It's array. It should create a string representation of the array it receives as the parameter and return it. Brush up on using string builder in part 10.3. Before taking on this exercise below, there are a few examples of how the method is expected to work.
In your ear this way, don't you tell a single soul what I'm going to say. Christmas Eve
Alright,
coming soon.
I'm not very good with multidimensional data, but will be a great exercise anyways.
Tell me if you can. When the clock is striking 12, when I'm fast asleep, down the chimney, broad and black, with your pack you'll creep. All the stockings you will find hanging in a row. Mine will be the shortest one. You'll be sure to know.
Alright. I spent a couple of time here because I was printing the rows and columns, and that kind of stuff was not needed. After let's redo some right here. After paying attention a little bit, I noticed the simple output was only printing the values. The values was right here, as you can see. But anyways, that doesn't matter. Magic square. In the exercise base, there's a partially implemented class called Magic Square that you can use as a basis for our program. Your assignment is to first add functionality to the class so that it can check whether a given square is magical. After this, you will implement an algorithm for creating a magic square. Some sums of rows. In the class magic square, there's already a method called public ArrayList, which returns an empty ArrayList object. Change the functionality of the method so that it returns a list of sums of every row of the magic square. For example, with the following magic square, the sum of rows method should return a list that contains the integers. Even if the magic square is not a legitimate magic square, the sum of the rows should still be returned. With the input below, the sum of rows should return a list with the integer contents. Alright.
your pack, you'll creep. All the stockings you will find hanging in a row. Mine will be the shortest one. You'll be sure to know.
Sums of columns. There already exists a step for the moment public ArrayList sums columns. Sum of columns. At the moment, it only returns an empty array object. ArrayList object. Change the functionality of the method so that it returns a list that contains the sum of every column of the magic square. As an example, when receiving the following magic square, the sums of columns should return a list that contains the integers. Even if the magic square is not a legitimate magic square, the sum of columns should be returned. Below, the sum of columns method should return a list that contains the integers 12, 15, 13. I just copied the code of some of rows because I think it's something like that. But I'll change some field. I'll make some field adjustments here. I think that's the word adjustment. I don't know. Some correction. Alright, I think it's just that. How I'm gonna know? Just when I send the test, the logo test. Let's continue. Sum of diagonals. Let's see the pronunciation here. Diagonals. Next, implement the method public create sum of diagonals that return the list with the sum of the diagonals of a magic square. With the following magic square, for instance, the method should return the list with the contents 15, 8 plus 5 plus 2, and 4 plus 5 plus 6. Even if the square is not legitimate magic square, the sum. Okay. Conjuring a magic square. Nota bene, this part might be tricky, so you might want to return the previous section before beginning it. It's also possible to create a magic square of your own. Let's familiarize ourselves with the Siamese method. Can be used to create magic squares that have a node size as opposed to even. Siamese method algorithm works in the following manner. We set number 1 to the centermost column of the top row. After this, we move one row up and one column right and place number 2 in the cell. We continue by moving one right, one up and placing the number 3, etc. 2 rows govern the number placement. If the transition would leave us at the bounds of the magic square, we jump to the opposite edge. In other words, if we go over it, the right edge, we continue from left edge, and if we go over the top edge, we continue from the bottom. The place already contains a number. We don't go up and right. Instead, we take one step downwards. Check the visualization for the described algorithm on the Wikipedia page. This mode. Implement in the class magic square factory the method create magic square. It should return the magic square whose side has the length that is specified as the parameter. The method only is to work in cases where the width of the square is not integer. Alright. reviewing the code. Reviewing the code, I noticed I made a big mistake here. I simply did the diagonals code on the sum of columns. What a mess. But anyway, we can fix that one. Look, it's I simply replaced it both inverted. Look, even here, some of diagonals we have the sum column. But anyways, fortunately, this is only an exercise, but we need to pay attention to don't commit these errors. Compilation fail. Why? What did I do? What did I do that make the compilation won't work? Set that cell. Let's test on the IntelliJ. See what happens. Program still work. No compilation error now. The sum of rows, columns, and diagonals should be the same in a magic square. Test factory. Let's reveal the cone. Into row square, what? No. Everything seems okay here. And here on columns. What about we invert the order? I don't think we need this anymore. Let's see what happens now. Another error. I think with this magic square, yes, we receive a higher percentage. Let's submit the server to see what happens. Sometimes the local test, it's with a bug or something, but probably my code is wrong now. Isn't the JUnit problem? It's mine. Yeah. Dude, I don't know. I simply don't know what to do now. Some of the rows count in diagonal should be the same in a magic square. Okay, but I think I'm gonna send this to the Gemini. Or simply ChatGPT, because I don't know the answer now. Let's see what happens now. Great. Magic square. Oh, I made a mistake here. You know, a great use for AI. That's kind of problems using an AI energy stuff, you know. I was thinking the problem was here on the magic square. I'll probably spend the time here. I want any more in fact. Because the problem was here and the ChatGPT catched the error. And now the problem solution was sent. But that means that we finished part 12. Take a screenshot here. Close the exercise in here. And go to the summary. Like we need to read this. Suppose test array hash map. We can implement the same functionality using a hash table. Wouldn't hash table be a better option? And we do not have to worry about incrementing its size at any point. When we search for a value of a key from a hash table, we use the hash code method to find the indexes to search from. There can be multiple values at the same index, but no less. Then we have to compare the key we want to find, the value for the key of each key value, compare on the list using the equals method. When we search for a value of a key or index in an array, we do not have to do any of that. An array either contains a certain value or it does not, so there is a small performance benefit on using arrays. This performance benefit comes with some added workload and proneness. Proneness to errors. Hash tables have tested and proven functionality for increasing the size of the table. Words do not come with this benefit, and when And when implementing a new functionality, we might cause errors, which increase the workload. However, errors are accepted and natural part of software development. When we consider the memory usage, hash tables might in some situations have some benefit. When an array is created, enough memory for the whole array is allocated for it. If we do not have the values in each element of the array, some of the memory stays unused. With hash tables, this does not happen. The size of the hash table is increased only when necessary. Summary. Using hash maps are the most commonly used data structure in programming. Understanding using these data structures are a part of every computer sciences and program is basic knowledge. This part we look into the implementation of a hash map and list and got introduced to genetics in Java. We also touched on randomness in multidimensional data. I know what a type parameter means. It can create classes that contain objects whose type can be defined with type parameters. I can use a data structure that resembles ArrayList. I can create a data structure that resembles a hash map. I can generate random numbers by using existing Java libraries. I can use multidimensional array. I think I forgot to read the summary of the part 11. I'm gonna do that right now. Conclusion. Finally, in fact, there was nothing super important to read. Now let's go to part 12. In fact, 13. 12 was that part, and we finish. Have a look on the ball. The 13th part of the course material introduced the topics of creating graphical user interface and the kind of components that are used in them. You will learn to handle different events that occurs in graphical user interface and practice creating applications that contain multiple views. Alright. So let's open the next. The 12 exercises. So, before all, in fact, I'm gonna create a new project here called MOOC.FI because we're gonna need this. Right, we're gonna need this to run the JavaFX. We see here JavaFX. This library gonna be used to add the functionality of creating a graphical interface. So here, web effect is being. Where is the code? Ah, that's not JavaFX. Here, JavaFX. Lib. Open all. We'll apply. Okay. And then edit. But let's create all this. Gonna need to create a new one. This here doesn't come with a XML MOOC.FI. Even I think I forgot to select Maven here. Alright. Libraries, Java. Voice. JavaFX. Click. Open. OK. Apply. Now we're gonna create a main here. Main. New application. Gonna call this main. Select that. And the virtual machine option. Then we're gonna go into the JavaFX. Start with the JavaFX. Your add VM options. And on the path here, we're gonna go on the Java effects folder, lib folder. Copy that. Alright, model path. Everything should be working now. Let's just start the program and see what happens. Yeah, I think everything working now. So let's read the course. Let's read this. Graphical user interface. We have 8 minutes. Enough time. Learning objectives. You know what user interfaces, UIs, consists of, and know how to launch graphical user interface, GUIs. We will now take a look at creating graphical user interfaces, UIs. In creating graphical user interfaces, we mostly make use of user interface libraries that provide us with ready-made components such as buttons and test areas. These user interface libraries take care of the drawing the components for us, meaning that we don't have to draw every single component in our program, only add them to it. Whereas test interface have the functionality coupled to a particular form of input, and GUIs is added to the user interface components. Programmer can, for instance, add a method to a button that lives on the interface which handles an event associated with that button. We will be using JavaFX interface library. We'll be using JavaFX user interface library to create our graphical user interface. The application will develop our desktop applications. Graphical user interface and require libraries. Library called JavaFX is used to create graphical user interface. In machine learning, you may have to install the open JavaFX library. Depending on how to install, you can install this in Ubuntu on the command line with the command Ubuntu. I kinda like Ubuntu, even though I prefer Arch Linux. A test library called TestFX is used in the exercise template to test JavaFX program. This library is included in the template while writes on macOS for exercise tab. Some of the tests in this section assumes that Teams NetBeans is able to freely move the cursor move the cursor around the screen on macOS, Apple computers. TMC NetBeans, TMC beans has to be granted this right explicitly. Here are instructions on how to grant this right. macOS help / macOS help. We can create a simple window. We can create a simple window using JavaFX with the following program.
A pair of skates. Susie wants a sled. Nellie wants a storybook. One she had.
We can, in fact, test this application here on the IntelliJ to see if everything is working.
Santa Claus, what you think is best?
In fact, isn't. So it misses something here. Application may. What I'm missing here? Model path. Add model. Oh, package. Oh, the code in the package. Let's have a look here. Oh, there's missing the. Oh my god. Look, public class name. Well, we add the name here. Addition. What I'm missing? Trying to restart the project. restart the program here. In fact, it's break time, and I'm spending the time that I should spend on the exercises. Oh, who cares? I continue the course after a lunch break. See you all after an hour.
going to say. Christmas Eve is coming soon. Now are you, dear old man? Whisper what you'll bring to me. Tell me if you can. When the clock is striking 12, when I'm fast asleep, down the chimney broad and black, with your pack you'll creep. 12 when I'm fast asleep. Down the chimney, broad and black, with your pack, you'll creep. All the stockings you will find hanging in a row. Mine will be the shortest one. You'll be sure to know. say Christmas Eve is coming soon. Now are you, dear old man? Whisper what you'll bring to me. Tell me if you can. When the clock is striking 12, when I'm fast asleep, down the chimney broad and black, with your pack you'll creep.
Hello. We are back to the game. We'll do one hour. We'll do 1 hour, uma hora a mais. We'll do 1 more hour and then finish the live stream. It seems that I'm unable to use IntelliJ because I can't configure the JavaFX library. But anyways, let's use the NetBeans. It sucks, but it is still usable. We stop it here. And the program is launched. Look as well. When the launch, I was trying to talk to GPT to help me out, but it couldn't. But anyways, when the launch method is called, the method of the application class creates a new object from the given class. Here's a JavaFX application. The call its init method. The init method is defined in the application class and is used, for instance, to initialize the object of a program. Calling the init method, the program calls the sort method, which gets a page object as its parameter, which describes the window and the implementation of the sort method above. The setTitle method sets the title of the stage type window object obtained as a parameter. The method show and then call, which leads to the window being displayed. The program then stays in a state where it continuously listens to events on user interface, such as closing the window that causes the application to shut down. My first application created a GUI app with the title of my first application. The app should start when the main method is executed. An application. We need to import the application. Import JavaFX application. Implement method start. An exception. Let's delete this. Also delete these. Launch orgs. So we need a window. We'll go with sort. Page, window, set title, page, go. The title. Let's submit this. Compilation failed. Why? Maybe the args they meant done the work. So let's write here application class. Oh, we need to. But what is the problem here? We have the void Start. Let's delete the exception. Void start page window. Maybe we need to report the application. What the? Any project? Oh dear, I'll need to use the Gemini to solve that problem to me. Send this, and let's submit direct to the server to see what happens. So on the server work, put here on the logo test, it gives an error. But anyways, let's go to the next structure of a user interface. Graphical user interfaces consist of three essential parts. The stage object behaves as the program's window. Scene set for a stage object that represents a scene within the window. The scene object, on the other hand, contains an object responsible for arranging the components. Components belonging to the scene, such as floor plan, which contains the actual user interface components. The program below is an interface with a single button. The application looks like this. UI components are added as children to the object responsible for setting them. Open. This has to do with the Java effect design decision, whereby each object responsible for UI components may contain other objects responsible for UI components as well as the actual UI components. This enables GUIs where the layout of the UI component depends on their location on the user interface. For example, menu items located at the top of a UI are usually placed side by side. Another list items are placed one below the other. Briefly summarize, the UI structure is as follows. The window contains a scene object. The scene object contains the object responsible for the layout of the user interface components. The object responsible for the component layout can contain both UI components and object responsible for UI component layout. UI components and their layout learn objectives. You are aware of some interface components and know how to add them to a user interface. You are familiar with the method for configuring the interface components. Programmers typically use a ready-made library implementing graphical user interface. As an example, it would make not much sense Implement a button from scratch, which would require creating a class that draws a button and handles all of its functions as pre-built button components can usually be found in existing libraries. Let's take a look now at some UI components. Tasks can be displayed using the label class. Label the label class provides a UI component for which tasks can be set and offers method for modifying the tasks it contains. The display of task is either set in the constructor or by using the set task method. Buttons can be added using the button class. Buttons are added the same way as the labels. Label, not labels. Label. Also have the ability to add multiple components at once. The example below, both a button and a task component have been added. The application look like this. You can find a list of the available UI components on the sign-out provides example on how to use them. There is a considerable amount of different UI components. Using online materials such as the one linked above is a good way to learn about them. When you're starting out, components should be tried out in isolation. By adding a single component at a time and inspecting how it works. Tree table wheel using the guy. What the component tree table wheel is and what it does. The task area below describe its functionality. Describe its basic functionality and what it can be used for.
Jolly old Saint Nicholas. one she hasn't read. Now I think I'll leave to you what to give her rest. Choose for me, dear Santa Claus, what you think is best.
As you become more familiar with the various components, using them become more straightforward. What's common to almost all of the components, the way that they're added to an interface. Once you know how to add one, you can add almost any component to your interface. The biggest difference in adding components is where they are placed on the interface. You will soon learn more about the lay these components out. Only thing is an example above, with the user interface containing a button and a label. Label to the class, the exercise template. The label must be either on top or left, or on the left side of the bottom. At least I have the impression that the template is already here is already correct, but on full parent component level. But on test field, create a graphical user interface to the class in the exercise template. The interface must contain a button and a test field. The test field can be implemented using the test field class. The button must be on the left or on the top of the field of the test field. Create a graphical user interface in the class that's supplied with the exercise bed. It should contain a button and a test field. You can implement the test field with the help of the test field class. The class button should be replaced above or on to the left of the test field. For some unknown reason, I also have some troubles with executing a Java fast code on the NetBeans, which is kind of funny to think that it should work here. But anyways,
down the chimney, broad and black, with your pack, your queen, all the stockings you will find hanging in a row. Mine will be the short one. You'll be sure to know.
let's see what Geminis think about this.
Johnny wants a pair of skates. Susie wants a sled. Nellie wants a storybook, one she hasn't read. Now I think I'll leave to you what to give a rest. Choose for me, dear.
Alright,
What you think is
we also passed that one. I think I'll just continue that way. It doesn't matter, in fact. UI component layout. Each UI component has its place on the interface. The location of a component is determined by the class user to lay out the component. In previous example, we use a class called FlowPane to set up our front-end component. With the FlowPane component that you add to the interface are placed side by side. If the size of window is reduced so that the component no longer fit next to each other, the component will be automatically aligned with the image below. The application resulting from the previous example has been narrowed so that the components are automatically aligned. Border pane. The border pane class lets you. The border pane class lets you lay out components in 5 different primary positions: top, right, bottom, left, and center. Traditional applications such as the web browser you are using take advantage of this layout. There's a menu and address. Up at the top and in the middle in the corner of the page. Other pane. Create a graphical user interface in the class provided in the exercise template. It should use the border pane class for laying out the component of the user interface. Add a test component at the top edge of the window containing the test north, and a test component along the right side containing either the test east, and a test component at the bottom edge containing the test south. Bem, falei mal, mas falei. Falling man, falling mal, mas falling de mim. Each box. Each box class enable UI components to be laid out in a single horizontal row. As evident from the previous example, each box by default completely includes UI component to each other. We can use the setSpace method to add space in between the components. The class VBox works in a similar way. Instead sets the components in a vertical column. Grid pane. The grid pane class can be used to lay out the UI. Lay the UI components in a grid. The example below, we create a 3x3 row in which each cell contains a bottom. this is an interesting implementation. The grid layout, grid pane. It's the same logic as the rows and columns that we use on the multidimensional subchapter. Multidimensional data. Anyways, multiple layouts on multiple layouts on a single interface. Layout components can be combined. The typical setup involves using the border pane layout as a database with other layouts inside it. The example below, the top of the border pane contains a H-box used for horizontal layout and a V-box used for vertical layouts. The task box has been placed in the center. As the statistics create an application in the class provided in the exercise template. Use the border pane class for the layout. In the center, there should be a test field created using the test area class. And along the bottom edge, there should be 3 test components. Place the test component along the bottom edge into a H-box object. The first test component should have the test matters 0. The second test component should have the test source 0. The third test component should have the test units word is. Well, let's do that last exercise from that subchapter. So I'm gonna finish that one and end the live stream. Alright, as we finish that last exercise, I'm gonna end the live stream now. Tomorrow probably I'll do a live stream. And I think on Friday we finish that course. Alright? The part 14, not so big as it looked like. The part 13, not hard as well. Not big and it's not hard. As we can see, only the multiple wheels. I'm gonna spend a couple of time here. And part 14, the data visualization. The rest of here is okay, you know. And I'm gonna try to solve the problem that IntelliJ isn't working with JavaFX. Even the NetBeans isn't working, you know. I can't test locally. I only can submit to the server. If I try to test here, it gives me an error message. I'm gonna, as you can see here, you can even try to run the program. But anyways, I see you all tomorrow.